The 17th question is to solve polynomial equations by factoring. And here we need to use these two important formulas. Now these are sum and difference of cubes. You can see here there is a cube, b cube. It's not a whole cube. What is the difference in the whole cube? If it is a plus b the whole cube, we will have parentheses or brackets. But if the cubes are individual, you're cubed and then cubed, the formula is different altogether. Over here, it'll start with a cube, a power 3 plus 3 times a squared b, and so on. It goes on. From Pascal's triangle or binomial theorem, we can find it. But here, it is cubes individually added or subtracted to each other. So the formula differs, and these are the formulas. It is easy to remember if you know the pattern. Whenever there are sum or difference of cubes, remember you have to add them both, a plus b. If this is plus, it starts with the plus, a plus b. And then a square, ab, b square is there, but over here after a square it's minus. If you recall, a plus b the whole square is a squared plus 2ab plus b squared. And if it was minus, this would be minus, right? Similar to it, but there's no 2. But if it is plus here, already you're using plus, this will be minus. But if it's minus, you can see it's a minus b. And all these parts will be plus. A squared plus ab plus b squared. Please remember these formulas because they are very important to solve the problems. Now let's solve a few problems here. 8c cube minus 27d cube. So you need to make the whole cube over here. See, the constant is there, right? Now it's only this. This and this are two different things. If there is bracket, it's a whole thing. Parenthesis makes it a whole cube. And then we can use the formula. I can't use the formula like this. You know, I can't use the formula of a cube minus b cube. No, why? Because this entire thing is not cubed. Only c is cubed. So you basically have to take the cube root of this and then you can make it a whole cube. Same thing over here, take a cube root and then you can make this a whole cube. So how would you start solving this? Because I'm sure you may not directly remember the cube root of 8 and 27. Let's use our calculators to get those numbers. All I'll do is, see, look at this number 8, right? So I need to use cube root. Either you can press shift and this over here, x power symbol. And now you can type this 3 over here, cube root, and 8. Or I can directly press shift and you can see this over here, square root. If you press shift and this, it's going to be cube root. So that is 8. And now just change the number. Cube root of 8 is 2. And this is 27, that's 3. So now what we do is we just write them as 2c the whole cube minus 27d the whole cube. Okay, now we can factor them out. Sorry, it's not 27 over here. It should be 3 because the cube root of 27 is 3. If at all you don't get a whole number, integer, then you cannot solve this. Then they are prime. Over here you can see right prime if they cannot be written in this form. But here you can. So let's write this out. Now we can use the formula. The formula is a cube minus b cube. That is equal to, since it's minus, first I write minus a minus b. Then it's just a squared plus ab plus b squared. And now let me do over here. Okay, let me write the direct substitution. A is whatever this over here. Let me just change the color. See, whatever is over here is a. And this over here is B. So what I do is, let me change the colors for B as well so you'll understand. This is B. So it starts with what? A, that is 2C. Then we go to B, that is minus 3D. That's it. Now look, we don't write the cube because we want only A and B. Whatever is inside the parentheses or the brackets is A and over here B. Now next thing is A squared. Open the brackets. A squared. That is again 2C. Now how do you square it? Is it only to the C squared? Because I know sometimes students do this mistake. They write 2C squared. Wrong. A is the entire thing. So over here, the square will be again in the brackets. Now, plus, just write again only A, that is 2C. And you have to multiply it with B. What is B over here? That is 3D. And lastly, we have to add it up with B squared, that is 3D the whole square, remember. So now this entire bracket is closed. You can see this is A squared, AB, B squared. Now the left side remains as it is. We can't simplify that. It's two different variables, 2 and 3. 2c minus 3d. But what happens over here is you square this 2c squared, it's going to be 4. The square is individually multiplied to both. Okay, it's 2 squared and c squared. And now this is the answer. If you had written in brackets, it will be 2c, but now we have removed the brackets. That means distribute this power to both the terms because they are multiplied. If it was added or subtracted, you had to use the a plus b the whole cube formula or a minus b the whole cube formula. But if it is ab the whole square, this is simply a squared b squared. That's it. There's no formula. Whereas over here, if it's plus or minus, it changes drastically, isn't it? So this is the formula here, and over here, this is the formula. So since there is nothing, it's just multiplication, we write it like this. Then plus. Now what happens over here, it's just multiplication. 2 times 3 is 6. C times D is CD. Plus 3 squared is 9D squared. So this is it. And now you can, remove common terms. I think so. This is enough. Let's just check the answer because we have simplified it, factored it out. Yeah, that's it. Because you can't take any common. Say it's 2 is common in these two. 3 is common. We can simplify. We have used the formula. We have factored it out, and that's the answer. Let's do the next one as well. What we do over here is check for 64. It is 4 and okay, let me just go back. And over here there is no number, it's just 1. 1 cube root squared, anything is 1 itself, so no bother. This is 4, but the problem is we have x power 4 plus xy3. So there is no way we can factor out like this, isn't it? So what we do is, if we remove this 1x from both, then this becomes cubed, and over here x is gone, we have y cubed. It's all win-win situation, right? So let's remove this x from as a distributive property. It's gonna be 4 cube, x cube remains. Why? Because out of 4, 1 is gone out. Plus this is gone, you're remaining with y cube only. So now if you multiply this back in, you're gonna get the above equation. So we have done nothing wrong. If you multiply it over here, it's going to be 4 cube or 64, x to the power 4, because 3 plus 1 is 4. And over here, it will be x times y cubed. So this is the thing. Now let's write it as a whole. X is what? 4x the whole cube plus y cube. And now we use, now here it was some difference of cubes. Now we have to use sum of cubes formula. Write it up over here. It'll be a cubed plus b cubed is equal to a minus b. See, it's a plus b. Whatever is over here, you start with that. Okay, and then over here it will be a squared minus 2 times ab plus b squared. See, over here, because it started with a cubed minus b cubed, minus is first. So this is how we write it. And now let me just write it out. A is this, b is this. So it's going to be 4x plus y multiplied with, so this is all multiplied. So 4x the whole square minus, okay, now wait a minute, I've written the formula wrong. I got carried away. It's not 2 times ab, it's a and b only. Okay, there's no 2 over here, it's just a times b. That 2 is only there in a plus b or a minus b the whole squared formula. See, what I would suggest is during the exams, first of all, be thorough with the formulas, understand it. If you by heart them, you tend to forget and you tend to do mistakes. So get a pattern in your mind. Doesn't matter how many formulas, it just automatically comes to me now. That's because, obviously I've been teaching for a long time. But otherwise as well, when I was a student, I used to find a pattern among the formulas. And that pattern will, help you to remember easily. You need to figure out which helps you the best. So try to understand all this as a figure or something in your mind. Now let's continue over here. A squared is done, minus a is 4x times b is y plus y squared. Now, another thing which students tend to get confused. So what happens is somehow they look at this, it's y cubed, right? So though they know that y is b, students write over here cube the whole square, or over here in the middle especially, they write this as cubed or something. Please avoid these mistakes. Though it is simple mistakes, students tend to do that. So that's why I'm repeating it. Now here, let's simplify how much we can. X as it is 4x plus y, and over here we have 16x squared minus 4xy plus y squared. And you can multiply this inside if you want. I think so this is fine, this is good enough. Let's just look into the answer, how much they have simplified. Yeah, that's it. So they have done only so much. We leave it over there. Now we will do the third question. In fact, I did this a while ago in the wrong type, and then I re-recorded it. I removed it because it's not that I was completely wrong. You can do that, but you won't be able to simplify it to the fullest. It'll be more complicated. So looking at this, you should realize that you need to, do some simplification. You can see that a squared is an odd man out over here. So what we will do is we'll remove the a squared term outside, and we will remain with a squared is gone. So it'll be from both of these 8 minus 2, that'll be 6 minus b to the power 6. Now we can't directly use a cube minus b cube formula, that is a minus b and a squared plus ab plus b squared. What we need to do is we need to get into this cubed, right? How do we get it? We need to write some power multiplied by another power. In the sense, imagine you have a power 4. You can write this as a squared the whole squared. Why? Because when you power the power, it'll be multiplied. Like 2 powers means it'll be a 2 times 2 is 4. That's how we get it, right? So now here, what are the two numbers when we multiply we get 6? It's either 2 times 3 or 3 times 2. So I can write it as a cubed the whole square. That is equal to also a squared the whole cube. It's a to the power 6. I can write any of this and get this, isn't it? Now choosing which one. Now the thing is, if you directly use the cube formula, here it's already squared. So it'll be complicated. In fact, you'll get a to the power 4 and everything. And it's very hard to simplify. So always in such cases, remember, there is this is difference of cubes, and this is the most appropriate way to use it. But there is squared outside, right? So do you know, if we write like this, say a squared into a cubed the whole square minus b cubed the whole square, this is another identity now. That is a square minus b square. Do you know this identity? It is a plus b, a minus b. Now, if you use this identity first, then simplifying the above becomes easier. Now, how would you remember this? Always remember, it's better to put the higher power inside and the smaller power outside. Why? Because the simplification of squares, this is difference of squares, this is difference of cubes. The difference of squares is simpler. So now if you use this, squares at the outermost, we can use difference of squares and simplify this, and then we can use the difference of cubes. But if you do the other way around, it becomes more complicated, and this you cannot use it basically. I mean, you can, but it just becomes more and more complicated. So what we do is, as a thumb rule, try to remember whenever you have, say, 10. Okay, this is not gonna, but it's better to write it as phi the whole power 2, the bigger power inside and the smaller power outside the brackets. I hope that is clear. So now what we can do over here is, I'll write it over here. A square outside, let it be as it is. But here, whatever is inside, first we have to use the difference of squares. It basically becomes A plus B. But what is A for us? Whatever is inside the square root, square, isn't it? So it's A cubed. Plus, what is over here? B. It's B cubed. And it's not over. Again, it is A cubed minus B cubed. So this is the simplification. Next, what do we do is, we have to use the sum and difference of cubes. So here A cube plus B cube formula is what? It is equal to, first we write plus and then over here it will be minus. So this is it. So let's apply the formulas. Here we have A plus B, and then we have A squared minus AB plus B squared. And what about over here? It will be A minus B. Here it will be A squared minus AB plus B squared. So this would be the simplification. So that is how we can expand this. Basically, let's just quickly go back. First, use the difference of squares, and then what you do is you use the sum and difference of cubes and split it out. That's it. Within 4 steps, you can easily solve the answer. The detailed steps are over here. You first remove the square out and everything, and then finally get the answers. We can see this is similar to the previous one, but there is one thing I forgot to tell you in the previous problem. Here you can't use what we did just a while ago. You can't write this, say over here y cube can be taken out common. You can't write it as x to the power 3 the whole square plus y cube the whole square. Can you think for a minute why we can't use this? Because there is no identity for a squared plus b squared. There's literally no identity for this, whereas there is difference of squares, that is a squared minus b squared is equal to a plus b, a minus b. It simplifies, but there's no identity for this. So if it is plus, we cannot use this, so we have to do other way around. Take the squares inside and solve it up. The cubes will be out. Use the difference of cubes formula, that is a cube plus b cube, and simplify it. But whenever there is minus, please remember whatever I told you just a while ago in this is only when there is minus. So whenever there is minus, have the cube inside, the higher power inside, then the smaller power. So we can use the difference of squares and then solve it up. But here, since we do not have the formula for plus, we directly go with the cubes because there is no other way, right? So we use the cubes, and now a is basically x squared plus y squared, x squared the whole square, and so on, because there wouldn't be any other method to go with. Similarly, you can solve these problems. Okay, now look at these terms. Over here there is 5, there is 18. There is no way we can get this as some number times x the whole cube, whole square or whole cube. Why? Look here, we need to write this x squared the whole cube. That's fine, but how would you write 18? There is no integer. Basically, there is see, it's not an integer that can be equal to the third power. So how do you check is, let's take our calculators. In this cube root, right, just put 18 over here. It will never be a whole number. It's 2.62. It just keeps on going, right? So there is no way you can write this as a whole number or a integer the whole cube. And what about the other number as well? 5 also, it's not possible. See, there is no way. So therefore we call it prime. Even this one over here, there is 2. So there is no way we can do it. This is also prime. You can't use the formula over here. And okay, this is a different type of problem, similar to what we just now learned, but it varies depending on the number of terms. Can you see there are so many number of terms here, right? How would you solve it? There are different methods. Some would say, okay, look at the alphabet, first alphabet, GG, group them, HH, group them, and so on. You can see over here there are three x squares. So let's write them first together. X squared g x squared minus 3hx squared plus 6fx squared minus 6fy squared. Remaining is y squared. So let's write them together now. And 3hy squared. Now what I will do is from all these three terms, I will remove x squared as a common term. Now what remains is it's g minus 3h plus 6f. Over here, what am I going to do? See, you need to relate this, whatever you have got over here. Just look at this. You can see 6f minus 6f. Positive g minus g, whereas minus 3h plus 3h. So what I'm going to do is I'm just not going to take out y squared, not plus y squared. I'll take minus y squared outside from these three terms. So these three are basically over here, and now these three are over here. When I remove minus y squared out, the sign changes for each term. And let me write first as g. What is this going to be? G term. Minus is gone, y squared is gone, you're just remaining with plus g. And what about the next 3h term? Y squared is gone, and from plus minus is gone, so it'll be opposite sign, it's negative 3h. And what about this? Minus is gone, so it's plus 6f, y squared is gone. Now you can see these two terms are same, this and this. Can I take this common outside? In the sense, from x square and this particular term, I can remove it common. So how would I tell it better is, imagine this entire term to be u, and this is also u. So I can write this technically as, let me just write it over here. Instead of u, I'm just assuming this entire term to be u. Instead of this big term, I'm just writing u. It will be yu squared. Sorry, it's not y. It's u, only u, minus y squared u. So u and u is common because they are the two same things, right? So I will take u common outside. So I'm getting y squared minus x squared minus y squared. I hope this is okay. So now what I'll do is I'll substitute what was u assumed to be. U was basically, it's g minus 3h plus 6f, isn't it? Let me just substitute it back. And what is remaining over here? X squared minus y squared. I can't stop it, it's nearly done, but I can see here it's x squared minus y squared. And we know there is a squared minus b squared formula. It's a plus b, a minus b. When they ask us to factor completely, what they are saying is basically to reduce the terms to the lowest degree as possible. If it's higher degree, it's complicated. The lower degree, the more better. So now, let this term be over here, g minus 3h plus 6f. But here, instead of x squared minus y squared, I'll write it as x plus y, x minus y. And this is the most simplified form. You don't multiply these back. You're going to get this only, but this is the most simplified form. You can see that would be the answer, right? Yeah, it's x plus y, x minus y. And they have written first 6f plus g minus 3h. However you write it, it's fine. See, it's a writing exam. If you write so much, you will definitely get full marks. So that is how we solve that. And over here, another similar problem, not the same one. I'll do this one as well. Here, I would always go with x squares. Okay, it's up to you. You can try a, b, c. Okay, how about I'll change it now? Now I will go with a, b, and c's. So let me write a's together. It will be 12a's x squared minus 10ay squared. Then let me write b's next, minus 18b x squared. And then we have, where is b? Over here. Plus 15by squared. And lastly with c, I'll write this first because 24c x squared is first and minus 20cy squared. Why I have written like this is when I remove things common out, the order is maintained. A x squared, sorry, a x squared y squared, b x squared y squared, c x squared y squared. It'll be easier now. Now, what do you remove common over here? You should try and see the maximum. I can't remove 10 because there are no 10s available both the places, but I can remove 2 for sure. If I remove 2 and this a's are common, if I remove 2a, what's remaining here is, it'll be 6x squared minus 5y squared. Now if you multiply 2a over here, you're going to get the above equations. So now what you basically do is take two terms at a time. These two terms over here. Now let me just take the next two terms. Here what will I remove common? I can see there is, uh, I can take a number that is 3, right? Because 15 and 18, 3 is common. You should just know the tables. Or you should just try to find a number which is common. You should divide both and you should get a whole number. But for this, you should know the tables in your mind. Tables are basically like, 3 times 1 is 3, 3 times 2 is 6, and so on. If you know this in your mind, then you can easily get the terms in your mind as well. Now, whenever you're taking terms outside, right, remember to make the inner terms equal. See, whatever is inside the bracket. And that will happen. For such problems, that will be there. They will give you problems such that you will have common terms. So here, I know x squared and 6 must be positive. So if I remove 3 out, it's not going to help me. Why? Because it'll be minus, sorry, not only 3, 3b, right? It's going to be minus 6x squared, but I want positive, so let me take minus as well. So now what's remaining is 6x squared. Here it will be minus because it's plus, minus is out, 5y squared. And lastly, what do we have here? You can see for this particular term, it's plus, so that's fine. But over here, what do you remove common out is, you can take 4 common out because 5 doesn't work. 5 works over here and not in 24. 6 doesn't work in 20 and 24, but 4 works in both, isn't it? 4 6 times is 24, 4 5 times is 20. So I will take plus 4 and the c outside. And now what is remaining? Here it will be 6x squared minus 5y squared. This is what's remaining. Now you can see that these are all common, same. So you can assume this to be u and take the u out. It's up to you. Or you can just take this entire 3 terms outside. See, now if you're assuming this to be u, then you remove u outside and what happens? You're remaining with 2a minus 3b plus 4c. And then you substitute this value, or directly you can you can directly solve it. How exactly? That is, let us just assume we are removing this terms outside. These 3 also are common, right? We remove it out. It will be 6x squared minus 5y squared. Okay, it's gone. So what are remaining inside the brackets? It'll be 2a minus 3b plus 4c. Now if I multiply this inside, I'm going to get this term, then this term, and this term. It's balanced, it's equal. I've not done anything wrong. I've just distributed them. I've manipulated them. That's the thing. If I use the distributive property, I'm going to get the above term. And even if I multiply it back inside, I'm going to get the question itself. So these 3 steps are enough. Now over here, I can't use the difference of squares. Why? Because here it's 6 can't be written as a square. So I leave it over here like this only. So you can see that's the answer. Don't go to simplify it further. So this is how we do it. If you're getting confused over here, take this as u. Write it as 2a times u minus 3b times u plus 4c times u, and remove the common term u outside, and then finally substitute what you assume to be u as. That's how we can solve this. And over here, all these problems are solved in detail. You can see them. See over here, what happens is, after you simplify, you have to use this formula as well, a cube minus b cube, which we studied, right? So apply the difference of cubes formula, and then you need to simplify further. I hope that is okay. And over here you can see x squared minus 16x plus 64 is completing the square method. Okay, so what happens is there's a completing the square method, but if you, now it's a little bit difficult. Anyways, I'll just tell you that. Let me just remove it out. If you have terms like this x squared, we just now had minus 16x plus 64, I believe. We can complete this as a square only by knowing the first 2 digits. How we do it is this entire term, right? Whatever is this, we just write it as x, this sign as it is. Now this term will be divided by 2. 16 divided by 2 is 8, the whole square. And whatever is this over here, this number, doesn't matter plus or minus, just subtract 8 square. And what is remaining here? Plus 64. So this much is basically this much. If you now substitute, if you solve this up using the formula, you're going to get x square minus 16. And now you simplify. Here, since this is a perfect square, right? What happens is, this is minus 64 plus 64. This cancels out and you're remaining with only so much. You will study this in the higher grades, I believe. I'm not sure this is done already for you, but this is the completing the square shortcut method. Now for your writing exam, if you may not get such big huge problems, where you have to use a lot of identities, but even if you get it, leave it as it is, x squared minus 16x plus 64. Leave it like this. That's enough. See, this last but one step is more than enough. Only if you can realize that this is okay, a perfect square, then yes, you can go ahead. Or you can also use your calculator over here. Since it's all in xxx, you can use mode phi 3 and solve it up and write it out over here. So that's also possible. And over here it's again similar. So you need to find some common terms over here, make them together. Over here all x are made together, over here all y's are made together. Now look here, you've taken the highest powers of x power 5, x power 4 and x cubed, and over here you can see there is common numbers as well, whereas over here other terms are taken, and then you remove the common terms out and try and get it and simplify it. Okay, these are now again a little different type of problems, so let's do one of this. Now you can use your calculator and solve it directly. I'll just show you now. You can use mode phi, and now don't go to 3, it's a quadratic, this is cubic, isn't it? Mode phi 4. Since all are a single variable, it's either x, x, x or a, something like that. You can use the calculator. The coefficient of a cube is 1, minus 9 and 14. And last term, there is nothing over here, it's 0. The constant is 0. So answer is 7, 2 and 0. You can see the final answer will be that. But how would you write this over here? So there are a few ways. Now, one trick way is from bottom you go above. So you know the answers. I'll write the answers. A is equal to 7, isn't it? And then there is 2 and 0. So let me write it. A is equal to 2 and A is equal to 0. So this is the thing. Now you can write over here up above, bring this inside. What happens? It becomes A plus 7. Sorry, A minus 7. A minus 7. And over here it will be A minus 2. And over here A minus 0 is just A. And then try multiplying these two binomials and write it upwards, because this is the answer. You're going up and up to this question now. A times A is A squared minus 2A minus 7A. This is just FOIL method, and plus 14. And this A is over here. Now simplify this. Let me write it as A squared minus 9A. Yeah, 9A plus 14 times A. And now if I multiply this inside A, what happens? It's A cubed minus 9A squared plus 14A. So this is how you can go as well. And this is absolutely right. Not to worry. Okay. Or technically over here now, if I'm solving it actually, what happens is, this is the calculator method. You write the answers and then you build the above parts. So some of the students would prefer this method because this is easier. You don't need to think of factors or anything. You can just keep on going up and you can solve it up. But when you're writing this, don't write this first and go down. No, that's wrong, because then obviously your teacher will understand you've done the calculator method and nothing else. But be a bit creative. Write the answers first, then go up, then go up, and then go up. I hope that helps you. I'll tell you how exactly you solve it. Here A is common, so we remove it outside. It will be a squared minus 9a plus 14 equals 0. And then how do you solve it further? This is a quadratic. You can find two factors. We need two terms which we need to multiply. See, 1 times 14. When we multiply, the answer must be 14, and when we add up, it must be minus 9. So 14, I can remember it's 7 times 2, because it's a, not a common number to have many multiples, many factors. So 7 and 2 I can easily tell, and it becomes 9, but it should be minus 9, so add minus and minus. That's the answer. So here what happens is it'll be a, and the factors of this will be a minus 7, a minus 2. And then we write this all equal to 0, isn't it? This is all equal. Okay, I forgot to write over here. It should all be equal to 0, this entire terms. And now what we do is we individually equate them to 0. A is equal to 0 first term. A is equal to a minus 7 is equal to 0 second term, and a minus 2 is equal to 0. So basically a is equal to 0, a is equal to 7, and a is equal to 2. You can directly write from year to year, that's also fine. So this is technically how we do it. And from here also you can use mode 5-3 and get the factors and solve it up to you. Okay. Now how do we do this one? First take it to the other side. It will be x cubed minus 3x squared. There is nothing over here, plus 0x plus 0 is equal to 0, right? Now let's take the calculator again and do the shortcut method. Press mode 5 and 4. It is 1 minus 3, 0 and 0. What's the answers? 3, 0, and that's it. So now in this case, right, if you have only two answers, see it's 1 and 0, right? You can't directly jump to the calculator method because there must be three answers. One of this answer is repeated. So, I mean, there are only few problems which will come like this. So what I would suggest is, you have written this, right? X cubed minus 3x squared is equal to 0. If it's a big one, it's easy to solve from the method which I just showed you. But for such problems, take the highest common out. What is common here? X squared and x squared. So if I remove x squared out, what's the remaining? It's x minus 3 is equal to 0. Now looking at this, I can tell we got x is equal to 3. Yes. Why? Because we have to equate this. X squared is equal to 0 and x minus 3 is equal to 0, right? Here x is 0, x is equal to positive 3. These are the answers we got, but we didn't know which is having the squared repeated root. So now from this we can understand 0 is repeated. If we go from the answers to back, I'm not sure where to write squared, over here or over here. So both would be correct, right? But actually it's only for 0 that's repeated. So for such problem, when they are very simple, remove the common term and solve it up. Let's see one more of this problem, and you can see all the details are over here. The solutions are just two over here. And now for this, there is, okay, some of the latest model you can do this also in the calculator up to 4 degrees, but in most of the calculators, most of the students which use calculator FX plus, this is not there. Only cubed is possible, right? So what you can do is either you can take t outside, but since I can see t squared and t squared is common, what I would do is I'll take t power 2 outside, and what am I remaining with? T power 2 minus 3t minus 40 is equal to 0. Now use your calculator and factor these terms out. Let me show you. Please use mode 5 and 3. 3 is for quadratic. And now what is before x squared? It's 1. And over here it's minus 3. And lastly we have minus 40. And the answers are, okay, it's just a bit loading. It's 8 and we have minus 5. So which do we write first? Don't directly write the answers. Write over here t squared and write these factors. It will be t. We got 8, right? Change the sign and write it as a factor. See, it's t is equal to 8, t is equal to minus 5. But when we write it as factor, it comes in, so it will be t minus 8, t plus 5. I hope you understand that. So over here you need to write t plus 5 is equal to 0. Now use equation to 0 to all these. Now if you're thinking why I'm equating everything to 0, now look at this. This is a single term multiplied with this, isn't it? So imagine any three terms or numbers multiplied to each other and you're getting 0. So that means any one of this must be 0, otherwise you can't get the answer as 0, right? So you're trying to find out, it can either be t square is equal to 0, or it can be t minus 8 is equal to 0, or it can be t plus 5 is equal to 0. Any of this can be the solution to give us the answer 0. So we solve it up. If t square is 0, t is also 0. Square root on both the sides, you get 0 itself. This is t, 0. Now here take this to the other side, it's plus, it becomes minus, it becomes plus 8. That's also possible. And lastly, it's minus 5. So this is how we solve this problem. You can see the detailed methods are over here. It's 0, minus 5 and 8. Lastly, please do solve this by yourself. You can directly find the roots. Now here, since roots are repeated, right, don't go to do it directly. What you can do is you can take a common term out, b square. Now this can be found out. Here what happens is you will have a single root. That means it's a repeated root. So you write b minus 4 the whole square, because x and y, x1, x2 is not there, only x is there. Your answer is 4. So you just write b minus 4 the whole square and then solve it up. And so the solution is 0 and 4. If you directly put in the calculator also you get this, but since in writing, so you have to do the steps. And the last problem is a real world problem. A modern table is constructed with 4 legs made of concrete cubes with cube shaped notches. Define one or more variable and write an expression that represents the volume of one table leg. So let's do one at a time. This I'll do later. It's, you can see this is a modern type of table, but they have tool, it's cube. So cube means it's all equal, but it doesn't look equal though. Please assume this to be equal, okay? This, all these sides are equal, and even the inside the notches which have been made, cube shaped notches, are also cube. That means all the sides are equal here. See that space which is cut. So we need to define one or more variables and write an expression that represents the volume of one leg of table. Okay, so we know this is cube. Now volume, let me just look at the answer, what exactly it is, and then I'll explain it. It's x cubed minus y cubed. Okay, I get it. Length of the side. Okay, so what we are taking over here is, let us assume the length of this cube be x. Okay, one of the side be x. So what is the volume of that cube? The bigger cube, it's x cubed. Let us take this opened up, you know, can you see the space which is opened up? This is also a cube, right? Let's take this side to be y. It's a smaller one, it's y. Okay, so what will be the volume if one side is y? It will be cube, because a cube volume is given by this x multiplied 3 times, you know, that time it's volume. If it was area, just multiply 2 times, you get the surface area. Cube is multiplying by 3 times. So these are the volume, this is the volume of the cube and this is the notch. How do we find the expression that gives for one one column or the leg? That would be basically x cube minus y cube. Let me explain why. The volume over here, volume of the, this is of the leg, this is of the notch. Now see, the total volume basically is x cube, yes, but here you can see some of the space is removed, the notch is removed, right? So this is the volume of the notch, this is the volume of the entire cube. So the entire cube minus the notch would give us the exact value, exact volume. I'll write here. Okay, exact volume, total minus whatever the hollow space, because when you're building it's not full, so that much is gone, right? That hollow space we have to remove it, so it's minus x cube. I hope that is clear. See here, that's how we get that expression. Now they have told Marisol determined that she will use 12,636 cubic inches of concrete to construct the four table legs. If the sides of the notches this, are 40% of the sides of the legs, how long are the sides of the legs? Okay, they have given us the volume of she will use to construct the four table legs. So for one table leg, how much did we find the volume to be? It was x cube minus y cube, right? But for 4 it is 4 times. Okay, so much of the volume is how much it's given us, 12,636. They have clearly mentioned it over here for all the 4 legs. But the problem is we have two separate variables, we cannot solve this. But they have told the sides of the notches are just 40% of the total. See, now if this is say 100 units, the side of the notch is 40 units. So basically, if this is 1, it's 0.4 over there. So what we will do is, y will be how much? 40% of what? X, because x is this and this is y. So y will be 40% of that. So what I do over here is, in x cube as it is, but instead of y, I will write 40% or 0.4. If you put in the calculator, I'll write it as 0.4 x the whole cube. This all multiplied, that is equal to 12,636. Now basically you need to use your calculator and solve it up. Here this will be cubed, okay? So it'll be 4 times. This is x cubed minus, what is 0.4 cube? It should be 0. I think so it's 0.64. So because 1664, yes, 0.64x cube. I've just cubed it as 0.4 the whole cube, and over here x cube. That is equal to 12,636. And now we can easily solve it and calculate it. Take this to the other side, divide both the sides by 4, and then simplify this. Let's use our calculators now. Let me just once again just check this. I am sorry, it is not just 64, it's 0.64, okay? Because when you cube it, it becomes reduced, and you have one decimal moves to the other side. Okay, it should be 0.064, my bad. Now what I will do is 1 minus 0.064. So basically 1 minus the answer is how much? 0.936, right? So x cubed minus 0.064 x cubed would be, it's basically 1 minus this number, 0.936 x cubed. And what is this divided by 4? Let's do it in calculator. 12,636 divided by 4 is equal to 3159. So here it is 3159. Now divide both the sides by 0.3936. So what I'll do is I'll just divide this by 0.936. It's 3375. So we have to just get x, right? So x cube is basically 3375. Now take the cube root over here on both the sides. So that will be x is equal to how much? So we have 3375, right? Just take the cube root, shift and this with the answer which is saved as 3375. The answer is 15. So over here we get 15, and it's a real number. So many centimeters, or what is it? Which dimension? Inches, inch cube, right? So cubic inches. So inches is the dimension that is used. So the x value, the original cube, is 15 inches long. And the 40% of that, just multiply this by 40%, you're going to get, it's about 6 inches, I guess, the notches. And you can see over here, this is how you solve it. Okay, now what they have done is they have used, see, everything is correct. Now lastly, I've just directly used the cube root and I've taken the answer, right? But in fact, there'll be 3 answers, but we don't get the imaginary answer directly in the calculator. But I'll show you how you will get it. See, we got this term, x cubed is equal to 3375. Now you can bring this inside. It will be x cubed minus 3375 is equal to 0. Now here, let's use calculator. Let's go to more, 5, and since it's cubic, let's go to 4. What is the coefficient of x cube? It's 1. But there is no x square and there is no x term and there is only 3375. That is the constant term. Now, if we solve it up, 15, yes, is one correct answer, but you can see there is imaginary numbers over here. So this is one imaginary number and they are always conjugate or pairs. Imaginary number doesn't come as one, it will come as two answers. So they are plus and minus. So that is the other answers. So we ignore the imaginary number. It's a real world problem. We have to have a real value. We ignore the imaginary part and take the real answer only. So that's how we solve this problem. That's the end of this topic. A very long topic. I hope you found it helpful. And a quick reminder, guys, if at all you have not yet subscribed to my channel, please do subscribe. It would mean so much to me. I'm trying my best to do all the other lessons as soon as possible, so please do stay tuned and use the playlist to find all the other videos.